Now that we have covered these fundamentals, let's move on to see how this process works in detail. As always, we start with the OAuth 2 roles. The client sends a POST request to the token endpoint of the authorization server to obtain an OAuth 2 access token. The curl command for this process is similar to the one used in the standard client credentials flow, but without any secrets or authentication parameters included in the request body. The authorization server verifies the request, and if everything is valid, it returns an OAuth 2 access token to the client. But how does this process work without including the certificates in the POST request? This is where mutual TLS protocol comes into play, showcasing its strong security compared to other client authentication methods. The authentication doesn't occur within the request itself at the application layer, but instead at the TLS layer. If you are familiar with the OSI model, it includes 7 layers. In the host layers, we have the transport, session, presentation, and application layers. With mTLS, client authentication is completed before the communication reaches the application layer. It occurs at the session and application layers as part of the TLS layer. Here is the completed curl command that includes the certificates. These certificates are not part of the HTTP request body, but are used during the mTLS handshake to exchange certificates and drive keys. Once the handshake is completed and the client is authenticated, it can then execute the POST request to obtain an OAuth 2 access token. If everything checks out during the TLS handshake, the authorization server generates an OAuth 2 access token and returns it to the client at the application layer. I will not go into deep detail about mTLS here, but let's briefly review a sequence diagram to understand how the authentication process works. In mTLS, we have a client and a server. Both the client and server maintain a key store and a trust store. This is because in mTLS, both need to exchange and validate each other's X509 certificates. A key store holds the public and private keys of the certificate and includes the entire certificate chain if there is one. On the other hand, a trust store contains trusted root certificate authorities. These are used to validate the signatures of incoming certificates. The TLS protocol operates on top of a reliable transported protocol, like TCP. After that, we have the TLS layer, where mTLS takes place, and then on top we have the application layer. The client initiates the process by sending a client hello message. This message includes information to secure and establish the connection. The server responds with a server hello, sending similar information and providing its certificate while requesting the client's certificate. The client validates the server's certificate using the root certificate authority in its trust store, which holds the public key. Then the client sends its own certificate back to the server. Next, the server validates the client's certificate using its trust store, which also includes the necessary root certificate authorities. If everything matches up, both the client and server calculate a symmetric key. This establishes an encrypted secure channel to exchange data at the application layer. So how does fit into OAuth 2? In this context, the client is the OAuth 2 client, and the server is the OAuth 2 authorization server. By the time we reach the application layer, the client is already authenticated. It can now make a POST request, such as in client credentials flow, without providing any further client authentication in the request body. The authorization server validates the request, and if everything checks out, responds with an OAuth 2 access token.